Hey guys, you ready to let the dogs out?
Inference in practice.
We're the three best friends that anybody could have. We're the three best friends that anyone could have.
Statistical inference provides methods for drawing conclusions of population from sample data and uses the language of probability to determine how trustworthy conclusions are. 4 requirements to make an inference. First, the data must be an SRS, which is a simple random sample. Second, the distribution of the data is approximately normal. Third, there are no outliers present. And fourth, we must know the standard deviation of the population.
Okay, so a confidence interval gives a probability that the interval will capture the true parameter value in repeated samples. The 68, 95, 99.7 rule states that each of these respective percentages are 1, 2, or 3 standard deviations away from the true population mean. So that means that our sample mean 68% of the time will fall within 1 standard deviation of the true population mean. 95% of the time it'll fall within 2 standard deviations plus or minus of the population mean. And 99.7% of the time it'll fall within 3 standard deviations of the population mean.
Guys, can you help me figure out the probability that my test score is the same as the average of everyone else's who took it using a confidence interval test?
In this example of the NAEP scores, we are given an SRS of 840 men ages 21 to 25, a mean of 272, a standard deviation of 2.1. Therefore, the 68, 95, 99.7 rule states that in 95% of all samples, the sample mean, which is X hat, will come within 2 standard deviations of the population mean score, mu, so that X hat of 840 NAEP scores will be within 2 standard deviations, or 4.2 points, of mu in 95% of all samples. If the sample mean is within 4.2 points of the unknown mu, then mu is within 4.2 points of the observed mean in 95% of all samples. So, 95% of the time in this sample, the unknown mu lies between plus or minus 4.2 of 272, or 267.8 and 276.2. The 95% confidence interval is between 267.8 and 276.2. A test of significance is used to assess the evidence provided by the data about some claim concerning a population, and an outcome that rarely occurs if a claim were true is good evidence that the claim is not true.
Wow, I'm so good at basketball. I make my free throws 80% of the time. Don't believe me? Well, let's test that out with a statistical test of significance.
Test of significance example, the claim is that Nick makes 80% of his free throws. The null hypothesis is that 80% of his free throws are made. The alternative hypothesis is that less than 80% of the free throws are made. Nick shoots 20 free throws and only makes 8. The probability of Nick only making 8 free throws, if he actually shoots 80%, which is our null hypothesis, is 0.0001. Since the probability of this happening is so small, we reject the null hypothesis and accept the alternative hypothesis as true.
Two-way tables. The purpose of a two-way table is to show the relationship between 2 categorical variables and to compare proportions. A table with R rows and C columns happens to be an R times C table.
I have a problem, guys. Please help me with that treatment and find out if it works using a two-way table.
Our example for a two-way table is solving cocaine addiction. We have 3 treatments for solving the cocaine addiction: the cypronine, lithium, and the placebo treatment. Our null hypothesis is that each of these treatments will have the same success of solving cocaine addiction, and our alternative hypothesis is that the treatments will not have the same success. So, to test our null hypothesis, we make a two-way table with the expected counts and the observed counts. If the observed counts are not close to the expected counts, then that is good evidence against the null hypothesis. So, we find our expected counts by multiplying our row total times our column total and divide that by our table total. So here's our whole two-way table for the example. With our treatments in the left column, our observed counts in the next two columns, and our expected counts in the final two columns. So, we tested each of the treatments 24 times. Cypramine, there was no relapses 14 out of the 24 times, and there were 10 out of the 24 times. Lithium, no relapses 6 times, there were relapses 18 times, and placebo was a little worse, with 4 times there were no relapses, and 20 times where there were, which isn't very good. If we remember, our null hypothesis for the whole experiment was that all these values would be equal to each other. And our alternative hypothesis was that they're not equal to each other. So now we ask ourselves, are these equal to each other? Now we answer to ourselves, no they are not. Therefore, we can accept our alternative hypothesis and reject our null hypothesis. The end.